So I'll just copy and paste this. Yep. So this method involves deducing our transformation by comparing our original function to our image function. So first, let us start off with our dilations as usual. So how do we go from -3 to 6? Okay, since we're starting with dilation, let's only focus on the 3 right here and leave the negative sign for now. So how do we go from 3 to 6? We simply multiply by 2, right? So it is a dilation by a factor of 2 from the x-axis. Always remember that when you're multiplying the whole thing, that is a dilation from the x-axis. Okay? Next up, we have our negative sign, and we don't have a negative sign here. So it is obviously a reflection in the x-axis. Yep. So now it's time to identify our horizontal translation, which you must be very careful with. So how do we go from, we'll get to horizontal translation last. The next thing we want to do is to identify our dilation from the y-axis. So how do we go from 2 to 1/3? Because you can see that coefficient of x goes from 2 to 1/3. How do we go from 2x to 1/3x, which is, yep, how do we go from that? From 2 to 1/3. We basically divide by 6. So that gives us, yep, so it is done by dividing it by 6. And remember, this is the part that makes the deducing method a little bit harder than the transformation equation part, which is the fact that you have to be very careful and remember that when you divide by 1/6, it is actually a dilation factor. Dilation by a factor of 6 from the y-axis, because we're always taking the reciprocal, and this has something to do with transformation equations, which I will explain in a later video. If you want to understand it, please leave a comment. So it is a dilation by a factor of 6 from the y-axis. And what do we have so far? So far, let us see. We have dilation by a factor of 2 from the x-axis. So that gives us 6e2x plus 5. And a reflection in x-axis. So the negative sign cancels out. And a dilation by a factor of 6 from the y-axis. That gives us 6e divide 2 by 6. That gives us 1/3x plus 5. So remember how I said that when you're trying to identify the horizontal translation, you must factor out the coefficient of x. So let us factor out the coefficient in front of x in both the modified function modified original function, and the image function. So y equals 6e 1 on 3x plus 15. And for our image function, it is -12. So you can see that these two look very similar. It is now very easy to see what the horizontal translation is by deciding how do you go from plus 15 to -12. You basically subtract 27, right? So you can think of it as replacing this right here with x minus 27 plus 15. That will give you x minus 12. So our horizontal translation would be translation by 27 units, right, since we're subtracting. And yeah, as you can see, we ended up with the same transformations, the same dilation. Yep, they're all the same. We have a dilation by a factor of 6 from the y-axis, reflection in the x-axis, and a dilation by a factor of 2 from the x-axis, and then a final translation by 27 units, right. And yeah, that's it for today's video.